Engineering application, flow systems and flow devices. The majority of devices and technical application of energy conversion and transfer involve the flow of substance. The majority of devices and technical applications of energy conversion and transfer involve the flow of substance. They can be passive devices like valves and pipes. Valves and pipes. And passive devices. And active devices like turbine and pumps. That involve work or heat exchanger that involve a heat transfer in or out of the flowing flow. Passive device as nozzle, diffuser, and valves or throttle. Nozzles, diffusers, and valve or throttle. A nozzle is a passive device that increases the velocity, as we said before, of a fluid stream at the expense of pressure. The shape, smoothly contoured, depends on whether the fluid is subsonic or supersonic. The large nozzle of the NASA Space Shuttle main engine was shown in the Chapter 1. A diffuser, basically the opposite of nozzle, is shown in this picture. For example, this is a diffuser. You have a diffuser here, high velocity and low pressure. High velocity stream of water, basically opposite to the nozzle, is shown in this picture, connecting with the flushing out fire hydrant without having a high velocity stream of water. A flow is normally controlled by operating a valve that have a variable opening for the flow to pass through, with a small opening in represent a large opening allows to the flow pass through freely with almost no restriction. There are many different types of valve used in the diffuser, which shown in the picture here. Ball valve, check valve, large butterfly valve, solenoid valve, and pipeline gate valve. Various valve can be used for a diffuser to deliver a low velocity stream of liquid. The next application is heaters, coolers, and heat exchangers. Heaters, coolers, and heat exchangers. Two examples of heat exchanger are shown in this picture. The after cooler for a diesel engine, shown in this picture, reduce the temperature of the air coming out of the compressor before it enters the engine. Reduce the temperature of liquid water before entering the engine. And the part B is to cool a hot flow or heat. The purpose, it is a heat exchanger. The purpose of the heat exchanger is to cool a hot flow or heat or cool flow. Cool a hot flow or hot a cool flow. The inner tubes acts as the interface area between the two flows, as shown here. We have two streams in the heat exchanger: active flow device and systems. A few air compressor, and fins are shown in this picture. These devices require a work input so the compressor can deliver air flow at a higher pressure and the fan can provide an air flow some velocity. A centrifugal compressor, a simple fan, and a large axial gas turbine compressor shown in this picture. As engineering application, different type of liquid pumps as active device shown in this picture. The different type of turbines are also shown in this. Let me provide it. Turbines picture. Turbines. The steam turbines outer stationary housing also has blade that turns the flow. They are not shown in this picture. The steam turbine shaft. This figure shows the large wind turbines and a turbine dam that using the dam for the water as fluid, gas as fluid, and air as fluid. we have air, gas, and fluid. Irrigation pumps, manual oil pump, gear pump, high pressure fluid in, it is a jet pump and rotating pump. The jet pump and rotating pump. This picture and also shows an air conditioner in cooling mode. In cooling mode, it has two heat exchangers, one inside that cools the inside air and one outside that dumps energy into the outside atmosphere. This is at the blowing out atmosphere. It is in the This is functionally the same as what happened in refrigerator. The same type of system can be used as a heat pump. In heating mode, the flow is switched to that the inside heat exchanger is the hot one and the outside is the cold one. There are many types of power producing systems. A coal-fired steam power plant, a shipboard nuclear power production system, and the other type of engine were also described before. This subject will be developed in the Chapter 11 and 12. This is the end of this section. The next section is a summary and also key concept and formulas.